Okay, students, so I'm going to go over some examples from this worksheet. One thing you know, bisect, as you see 1 through 4, bisects it. Bisects means splits in half. Got to know that. So into two even parts, or halves. Okay, and it says line RS. So here's an example of line RS right here. Okay. Bisects segment PQ, so I have to draw a segment PQ at point R. That's why R has to be on segment PQ. It bisects it, so that, remember we show that by hash marks, that they're congruent. And it says the entire length is 14 centimeters. So that's what we have right there. And since each of these is equal, then each half is 7 centimeters. It asks you to find RQ, 7 centimeters. Okay, so that's that example. Now you can go on and do the other three there. Down here on number 6, M is the midpoint. Midpoint, same idea. It splits in half. That's why you see the hash marks already here on all three of these. Okay, so each segment is equal. Set them equal to each other. Solve for x. Go back and read the question. It doesn't want just x. It wants the length from A to M. So now I plug in the 6 into the x here and get x plus 20 is 26. Okay, so that's for the other two. Next one, find the coordinates of the midpoint of the segment. Okay, so we have 4 problems here. We're doing number 9. Find the midpoint. You take the average of the x's, as it says here, plus the average of the y's, as it says here. So how do you find average? Since there's 2 numbers, you add 2 together and divide by 2. So added the 4 plus the 0, that's the x coordinates, divided by 2, and then 2 plus 2 divided by 2. And so you get 2 comma 2. Okay, so there's your midpoint. You do that for the other ones. All right, number 12 now. It says given one endpoint, R, and the midpoint M, find the other endpoint. So notice R is an endpoint, 6. We're dealing with the x coordinate right now. M is the midpoint, 0. How far is it from 6 to 0? 6. So I went back 6 here. I'm going to go back 6 from 0. 0 minus 6 is negative 6. Okay, so negative 6 is my x coordinate. That's why I have it right here, negative 6. And I can do the same thing with the y coordinate. Okay, starts at 0 for one endpoint. The midpoint is 2. That's the midpoint. So that distance is 2, so I have to go 2 higher. And that puts it at 4. And therefore you have negative 6, 4. Now another way you could do it, I did a horizontal and vertical. You could do both on horizontals, as I see here. So this, shown it 3 different ways. So this is just doing both on horizontal. And then over here, last way would be to plot the points and use your slope. So here's 6, 0. Here's 0, 2. And if 0, 2 is the midpoint, I know it has to be somewhere up over in here. Automatically, well, how did I get that? I went back 6. That's the negative 6 right here. And I went up 2, positive 2 that I have right there. So I do the exact same thing again. Back 6 and then up 2. And that takes to that point, which is your negative 6, 4. Okay, same answer. So if it's easier for you to use slope, then go ahead and do that. Okay, and do the other problems there. All right, next, we're doing distance on a number line. So all these are distance, right? Distance from A to B, A to D, C to D. So I chose to do 16, A to E. How far from negative 9 to positive 2? Okay, well, from negative 9 to 0 is 9, plus 2 more is 11. So one thing I had a plus here to just remind you that distance is always positive. You can never have a negative distance. Okay, so if you want to put plus signs to begin with on all these, just so you remember that you have to have a positive answer. Okay, then you can do that. Now, the other way, if you don't want to go how far from negative 9 to 0 and the 0 to 2, is you subtract in the order of right minus left. That's why you see this arrow right here, and you see the subtraction sign up here. So 2 minus the negative 9 is positive 11, and that will give you the positive answer automatically. If I was to go the other direction, I have negative 9 minus 2 is negative 11, and then I would have to take the absolute value. So if you don't have to take the absolute value to come up with a positive, just always subtract right minus left. Okay, next, down here, we see that A equals B, B equals C, CX equals that as well, and YZ equals that. So I can put X's on all those. Okay, and it tells me XY is 22. That's in there given. And it tells me XZ is 33. So now I should be able to figure out what X is from there. And then obviously it also tells me that this whole distance is 54. So after I get the X from down here from YZ, I can plug it in up here on these other ones and get the whole distance of CD from there. And you can answer those questions 19 to 24 now. Okay, next we have the segment addition posture. I'm not going to go through one of those examples. You just got done doing a whole page worth of them. Okay, these are the basic ones right here. Next page. You are trying to see if these statements right here are true or false. Okay, based off of this diagram right here. Okay, obviously we have vertical angles that are congruent. We have linear pairs that are supplementary. And so knowing that, check to see what they've written here, see if the statements are true or false then. All right, next group is we are drawing based off the given information. So I chose to do number 6. It says non-adjacent. That means not next to. Remember, adjacent means next to, so non means not. So it's not next to. They can't be touching. Supplementary angles means two angles that add 180 degrees, where one angle is 42. So if one angle is 42, 180 minus 42 is 138. So one angle is 138, one's 42, and they cannot be touching. So you see they're not touching. So I went ahead and did that drawing. So that's what you're doing in this section, making drawings that satisfy these conditions. Last one right here, last page. I put it in here so you can practice the skew. We talked about skew. Skew, remember, are two lines that do not intersect and are not in the same plane. They can never be in the same plane. Because we know if they're in the same plane, two lines that don't intersect in the same plane are parallel lines. Okay, and then perpendicular, obviously 90 degrees. Okay, so the one I did was number 3 here. If I look at QT, line QT right there, and line YS, let me change the color here, and line YS right here. Okay, so these lines, you can see if I extend them, they are not going to intersect at all, and they are not in the same plane at all either. So therefore, the answer is skew. Okay, and you go ahead and answer the other ones with parallel skew or perpendicular. Well, that's your 90 degrees. Down here, you are going ahead and identifying the line or lines. That's what parentheses S means. It could be a single answer or it could be plural answer that satisfy these things. So if I looked at number 10, as we did here, a plane parallel to plane FGC. So FGC is this top plane. Remember, you can name a plane in one of two ways. You can use 3 or more letters. They use 3. 3 is the typical one. I could have called it FGCD as well, plain FGCD. Or if there was a capital letter in one of the corners with no point next to it, that's the other way. Well, of course, they don't have that here, so we have to name it with 3 or 4 letters, okay, for our plane. So it's the top plane here. There's only one other plane that's parallel to that, and that's the bottom plane down here. And of course, you just pick 3 of these 4 or all 4 of those letters if you wanted to. And so we just chose plane EHB. I could have called EAB, I could have called BAH. Any 3 of those 4 or all 4. Order doesn't matter. Okay, that covers the video examples for this right here. 9 minutes.